So initially we'll try to start with a 1-bit memory cell. That is what we have discussed in last session, guys. So in what 1-bit memory cell, guys, okay, in 1-bit memory cell, we discussed about sequential circuit. In sequential circuit, along with the combination circuit, we will have a memory cell. Initially, in order to discuss or to design that memory circuit, they have used this kind of circuit, guys, which can store either 0 or 1, only 1 bit of information. That is why it is called a 1-bit memory cell, guys. Okay, so this is how your 1-bit memory cell look like with the combination of 2 NOT gates. Okay, and we discussed completely regarding this 1-bit memory cell. Okay, so which is having 2 inputs A and B. Okay, 2 inputs A and B and 2 outputs Q and Q bar. Okay, its inversion output Q bar will be there, guys. Remember, I told that after expanding this 1-bit memory cell, I told that it is having some limitations, like it only can work with a single input. We cannot give, or it is impossible to give both the inputs at a time. That is one limitation it is having. Okay, and few observations also we got to take from this one, guys. Okay, what are the few observations we got to take here? That we can give input, and we can give some output at the time, and we're having 2 outputs Q and Q bar, which are inversion to each other. Okay, and if you're having 0 as your output, guys, this is your very important note you have to take. If your output is 0, okay, if the output is 0, that output is called 0 state or 1 state. Okay, 0 state or reset state. Remember that, guys. If you are having 0 as your output, that state is called 0 state or reset state. Guys, what is that? Can you repeat? If the output is 0, what it is called? What it is called if the output is 0, what we call it as?
0 state or reset states.
Yeah, reset.
0 state or reset.
Reset state. Okay, so guys, very important, you should remember. Throughout the third unit, you will have this. Okay, reset state. Okay, one is reset state when you are having Q equal to 0. Likewise, if you are having Q equal to 1, guys, okay, if your output is 1, then that state is called, okay, then that state is called 1 state or set state. Okay, 1 state or set state. Okay, guys, remember that if Q equal to 0, what state we call it as? What state
0
we call it
on
as?
the reset state.
0 state, or we can call it as reset state. If the output is 1, what we can call it as?
1 state or set state.
Yeah, 1 state, or we can
state
call it
or
as a set state.
set
Okay,
state.
guys. Okay, that is what I want you guys to remember in 1-bit memory cell, guys. From that, now we are going to discuss about next topic, that is about a latch. Okay, latch, L-A-T-C-H, latch. Guys, understand the meaning of latch is capturing. Okay, if your circuit is trying to capture some output, then we can call it as a latch. These latches can capture or latch a single bit information, either 0 or 1. At that case, or at that time, if your output is 0, we can call the latch is under reset state. If your output of the latch is 1, we can call that circuit or latch is under 1 state or set state. Okay, remember that these key points, guys. Then I will show you how the circuit diagram or how this latch is going to work. Guys, all of you take your book and note down what are the topics I'm going to say now, guys. Okay, guys, now we have started with 1-bit memory cell. Okay, 1-bit memory cell. From that 1-bit memory cell, I'm going to design a latch. Look at here how the latch is going to look like. Look at here, guys. You got to say to me, and meanwhile you try to draw. I will ask what kind of gates that I'm using in here. Okay, guys, can you tell me what it is actually? What gate this is actually? What is this, guys? What gate this is actually?
NAND inverter, sir.
NAND
Yeah.
inverter, sir.
Yeah, thank you, guys. This is NAND inverter. Then I'm trying one more gate now. Meanwhile, you try to draw the circuit, same circuit, guys. Don't simply sit. Try to draw the circuit. Now, guys, now you tell me. Okay, you got to tell me that. Okay. Fortunately, gave some wrong connection here. Okay. Students, can you see the circuit now?
Yes, sir.
Yeah, students, listen here. You can draw it later. Listen to this, what I'm saying now. This is very, very, very basic and very, very important, guys. Okay. Now we are going to discuss something about SR-Latch. SR-Latch. Okay, since you can see there are two inputs, S and R, that's why it is called SR-Latch. S is actually abbreviate set, SET, set. And R is reset, guys. Okay, all of you can draw later. Please listen to the circuit operation clearly, because this circuit operation is very, very, very important. Unless otherwise you understand this operation of this circuit and what I'm going to explain now is very difficult to understand further classes. Okay, so based on this concept only, we are going to discuss the next topics here, guys. Look at here now, guys. Are you all ready? Can we start? Students, are you all ready? Can we start? What are you doing? Are you sleeping, girls? No one is replying.
Yes, sir.
Yeah, listen to this, guys, girls and boys. Look at here. This is called a SR latch. Since we have two inputs named as S and R, set and reset, we are calling it as a SR latch, guys. I told you in previous classes when we have started with sequential circuits, a sequential circuit can deliver its outputs or can produce an output based on its inputs, and also depends on previous history of the inputs, previous output, nothing but. Okay, I told you guys, the output of the sequential circuit is produced or depends on present input and past outputs also. Past outputs also, that is what I have said, guys. Okay, past outputs also. Listen, now I am going to describe the history or operation of this SR latch now. Okay, what it is called, guys? What circuit it is? What circuit it is? Guys, what circuit it is I'm asking? You have to answer. Students,
SR-Latch.
SR-Latch, okay. Then look at here how I'm going to show the output of this SR-Latch, guys. I told you in sequential circuits, the output depends on present inputs and past output also. So we should know what are the inputs I'm going to give, what is the previous output it got, then I can decide what is its output, guys. Okay, what is its output? That is what is called truth table of the given latch here. Truth table of the given SR latch. SR latch here. Look at here, guys. I have two inputs here called S and R. So I can give four possible input combinations. You already know that. What are the four combinations I can give if I have two inputs? If I have S and R, I can say 0, 0, 0, 0 is one input combination, 0, 1 is another input combination, 1, 0, 1, 1. Okay, I can give these four input combinations, guys. Okay, so using these four input combinations and different previous output combinations, I got to decide what is the output I'm going to get for the given circuit. Let us see how we have to discuss with that. Look at here, guys. First of all, I'm trying to give 0, 0 as my input. Okay, what input I'm giving, guys? Initially, what is the input I'm giving?
0, 0.
Clean the very, very important. That's why I'm very much particular about this. I'm giving 0, 0 as input initially, and I am assuming that previously I'm having 0 as my output. Previously I'm having 0 as my output. That is what my assumption, first assumption, guys. Since if you want to produce an output, you should know present inputs, what you are going to give, and you should know what is the previous output. I am assuming that if my previous output is 0, then look at here, guys. What happens, guys? You have to say clearly, I'm giving a 0 input S at S, and I'm trying to pass it through a NAND inverter. If 0 is passed through NAND inverter, what will be the output at the end? What output you will get here? If I'm passing 0 through a NAND inverter, what you'll get? If I am passing 0 through a NAND inverter, what output you can get here?
1, sir.
1, guys.
1.
Inverter means it will invert the input. 0 means it will give you 1. Similarly, guys, I'm having 0 at this end, and if 0 is passing through this NAND inverter, you can definitely get 1 in here. Okay, 1 in here. Now look at the twisted connection. What I'm having here, twisted connections. I have 0 at this end already. So through this lead, you can get 0 to this point. Okay, at this point you can get 0. Chunana ikkada already 0 undi. Through this line, that 0 will reach this point. Guys, remember one thing. If you are having 0 and 1 as your inputs to the NAND gate, 0 and 1 as inputs to the NAND gate, what output you will get? NAND gate 0, 1 as input. What output?
1, sir.
1, sir.
0, 1. 0 into 1 is actually 0 when it is a multiplication. Inversion of that
Inverter is 1, sir.
1 actually. So I'm going to get 1, guys. So at this lead, you are having 1. So through this line, this 1 will reach this point, guys. Okay, this point. Now I'm having 1 and 1 as my inputs to the NAND gate. What you will get as your output, guys?
0, sir.
0, sir.
0.
0,
Now,
sir.
guys, I got 0 as my output here. You need to observe one thing clearly. Previously, I have taken 0 as my output. 0, 0 input తీసుకొని previous condition లో నాకు 0 అనే అవుట్పుట్ వచ్చింది అనుకుంటే I got 0 again in the next state. ఇప్పుడు నేను 0, 0 ఇచ్చిన తర్వాత previous state లో 0 ఉంది అనుకుంటే నాకు ఏ అవుట్పుట్ వచ్చిందండి ఇప్పుడు కొత్తగా? What output I have got guys? What output I have got here, guys?
0, sir.
0 clear.
0, sir.
Yeah, 0, 0 అనే ఇన్పుట్ ఉంది తీసుకున్నాయి. ప్రీవియస్ స్టేట్ లో 0 ఉందని నేను ఆపరేషన్ మొత్తం కనెక్ట్ చేస్తే సర్క్యూట్ హ్యావ్ ప్రొడ్యూస్డ్ 0 as my output. Okay, that is what you have to understand here. Then guys, with few changes, let me keep this in the mind. So what are the assumptions that we have taken here, guys? I have taken an input 0, 0. Okay, 0, 0 input తీసుకున్నాను. ఇంకా ఏం చేశానండి? What I have done? Previous
Output.
state.
Past
Previous
output.
state. Past output is 0. Okay, past output 0 ఉందని అనుకుంటే నాకు నెక్స్ట్ స్టేట్ లో ఏం అవుట్పుట్ జనరేట్ చేయగలిగాను? వాట్ ఇట్ హ్యాస్ జనరేటెడ్ 0 back again. 0 మరలా వచ్చిందండి. Now let us go for small change. I am taking same 0, 0 as my input, but for a change I am trying to take my past output as 1. ఇంతకు ముందేమో 0 తీసుకున్నాను. 0 తీసుకుని 0, 0 input తో నాకు 0 అనే అవుట్పుట్ వచ్చిందండి. So keep that in the mind. Now let us take my inputs are 0, 0 again, but my previous output is what? What is my previous output, guys?
1, sir.
1. That is my assumption. Okay, that is my assumption. Already 0 అనే assumption తీసుకుని output ఏం జనరేట్ చేసిందో చూసాము. Okay, now we will see if I take 1 as my previous state or previous output. Let us see what is going to happen. Guys, again tell me, if this 0 is passing through this NAND gate, what output will reach here?
1, sir. 1, sir.
1. And again this 0 is passing through this NAND inverter. What I will get again?
1, sir.
Now previously, what is my output here, guys? What is my previous output?
1, sir.
1.
1,
So
sir.
through this 1 is already available in this lead. So through this line, that 1 will be reaching here. So if I'm giving 1 and 1 as my inputs, what you will get here,
0,
guys?
sir.
0, sir.
So 0 is available in this line. That 0 through this line will reach here. Okay. Now, guys, if I'm taking 1 and 0 as my inputs, okay, 1 and 0 as my inputs, what will be your output, guys? What will
One,
be your
sir.
output of NAND
1,
gate?
sir.
1,
1,
guys.
sir.
Okay, so you got to observe very, very important thing here. When I'm taking 0 and 0 as my input, okay, నేను ఎప్పుడైతే 0 0 అని input తీసుకున్నానో, and when I'm assuming that my previous output is 0, what output you got in there, guys? When I have taken 0 as my previous output, what output you have received again?
0,
Zero.
sir.
Now, when I'm taking 0 0 as my input, and when I have assumed that my previous output is 1, what output you have got now?
1, sir.
1,
1, guys. Okay, so you have to come to a clear-cut conclusion that when you are giving two inputs 0 0, okay, when I'm taking S is equal to 0 and R equal to 0, that what is your previous output? The same output you will get again. ఎప్పుడైతే మీరు 0 0 అని ఇన్పుట్ ఇస్తున్నారో మీరు ప్రీవియస్ అవుట్పుట్ ఏదైతే ఉంటుందో అదే స్టేట్ కి మరలా మీరు రీచ్ అవుతున్నారండి. దట్ ఈస్ వాట్ యూ హ్యావ్ టు అండర్స్టాండ్ ఇన్ దిస్ కంక్లూజన్. When your input S and R equal to 0, your output depends on previous state. Actually, what is your previous state? That will decide your next output when S is equal to 0 and R equal to 0. Guys, do you understand this condition when S is equal to 0 and R equal to 0?
yes, sir.
Guys, once again,
Yes,
I'm
sir.
saying when S is equal to 0 and R equal to 0, your output or next state will depends on present state. అంటే ఆల్రెడీ నా దగ్గర ఏదైతే అవుట్పుట్ స్టేట్ లో ఉందో ఆ అవుట్పుట్ స్టేట్ డిపెండ్ చేసుకునే మనకు నెక్స్ట్ స్టేట్ వస్తుందండి. when S equal to 0, R equal to 0 means if present state is 0, next state also will be 0. If present state is 1, next state also will be 1. That is what you have to understand, guys. Since your next state is depending upon present state, okay, means when Qn is equal to 0, then you are getting Qn plus 1. Means when present state is 0, you're getting next state 0. When present state is 1, next state is 1. We call that state as no change state. What we call that, guys? When S equal to 0, R equal to 0, what we call that as?
No,
No change. No change
change.
state. అంటే present state ఏదైతే ఉందో మనం అజ్యూమ్ చేసుకున్నాం అదే నెక్స్ట్ స్టేట్ వస్తుంది కాబట్టి we call that as no change state when S is equal to 0 and R equal to 0. Guys, now let me take another condition. Okay, let me take another condition, guys. That means different inputs. I'm saying different inputs we'll take and we'll see what are the conditions we may get for this SR-Latch. Okay, just a minute, guys. Let me erase the things. Okay, now look at here, guys. I'm going to take next condition that when S is equal to 1 and R equal to 0. This is what I'm going to take, guys. Okay, already 0 is 0 0 is over. Let me take S is equal to 1 and R equal to 0, guys. Now tell me, guys, when this 1 is passing through this NAND inverter, what output will reach here?
0, sir.
And I'm writing that 0. What about this one?
1,
sir.
Okay, now let us assume 1 is available in here. That means this is my previous state. Previous output ga naku 1 undanukunnam. Now through this line that 1 will reach here. Okay, guys, tell me what will be your output now when 1 is an and
0.
0 here, guys.
0,
Okay, 0 clearly. Then that 0 will be passing through this line and will reach here. When 0 1 are your inputs of an AND gate, what will be the next state you will get, guys?
1, sir.
1 here. Okay, this is the very important condition that you got to observe here, guys. Okay, even though if you take 0 here, in here, understand it, guys, even though if you take 0, you will get your next state as 1 again. మీరు 0 తీసుకున్నా కూడా next state ఇక్కడ 1 వస్తుంది, guys. Understand, when I'm taking S is equal to 1, okay, and R equal to 0. When I'm taking S is equal to 1 and R equal to 0, even if you take your present state, guys, I will write that as present state as Qn. Even if your present state is 0 or 1, your present state 0 aina 1 aina ఖచ్చితంగా next state అండి. That next state generally called as Qn plus 1. Qn is present state, Qn plus 1 is next state. We will notate it as always your next state or output will be what it is, guys. మీరు present state 0 గా తీసుకున్నా 1 తీసుకున్నా ఎప్పుడైతే మీరు ఇన్పుట్ ని 1 0 గా ఇస్తారో for that latch always your next state will be what it is. What it will be, guys?
1 sir.
1.
1 sir.
So when you're taking one S is equal to 1 and R equal to 0, irrespective of present state, means even though if your present state is 0 or 1, automatically your next state will be 1. Guys, I told you, if your output of a circuit is 1, what state we call it as?
No
One
change.
state or
One state or set state.
Yeah, so when you're taking S is equal to 1 and R equal to 0 for a SR latch, we call that as set state. Since you're getting your output as 1 in here, my output ikkada 1 vastundi kabatti, we call that state as set state. Guys, there is a small condition that we can remember here. Eppudu manam SR latch lo set condition ani cheppochu ante, look at here, guys. What value we are giving for S here?
1 sir.
And what value we are
1
giving for
sir.
0? What value we have given for 0?
R sir.
What value we have given for 0? I'm asking. Guys, S is equal to
0 or
1 and R
reset.
equal to 0 we have given, guys. Okay. S is equal to 1 and R equal to 0 are the inputs we have given. Right, tell me which one is high in between these two? Which one is high in between these two? S is equal to 1 and R equal to 0. Which is high? రెండింట్లో ఏది హై అండి? S is equal to 1 and R equal to 0 లో
S equal to 1, sir.
Yeah, S is equal to 1. So when set is high, when S is equal to 1, set is high, you'll get set state. In reverse, guys, in reverse, if you give reverse conditions, okay, I will tell you how the reverse condition can be given. Wait a second, guys. If you are giving a reverse condition that if S is equal to 0 is given, okay, if S is equal to 0 is given and R equal to 1 is given. Okay, let me give that value. Guys, we have completed two conditions, guys. S is equal to 0, R equal to 0. Okay, what happened to your output, guys, when I'm giving S is equal to 0, R equal to 0? What about your outputs? What is your output, guys? When S equal to 0 and R equal to 0 is taken, what happened to your output?
0 sir.
Guys,
0
remember,
resets.
when S is equal to 0 and R equal to 0 is taken, if your present state is 0, next state is 0. If present state is 1, next state is 1. And we told that as no change state. Okay, present state value ఏదైతే ఉంటుందో అదే మీకు next state గా వస్తుందండి. When S is equal to 0 and R equal to 0 is taken. And then we have seen next condition. When S is equal to 1 and R equal to 0 is given, okay, we call that state as set state because your output will be always 1 in that condition. Let me go for the next condition, guys. When S is equal to 0 and R equal to 1. Guys, tell me in between S is equal to 0 and R equal to 1, which is high?
R.
R,
R.
sir.
So reset is
R
high in
equal to
here.
1, sir.
Okay. So R reset is high. You remember that when reset is high, you should get reset in state. Output అనేది కూడా reset state లో ఉండాలండి. S is equal to 1 ఇస్తే మీకు set state రావాలి. అదే R equal to 1 ఇచ్చారంటే reset state రావాలండి. Means that always your output should be 0. Reset state అంటే output ఎప్పుడు 0 గా ఉండాలండి. Remember that. Guys, according to the condition, I'm taking this. When S is equal to 0 and when it is passed through the NAND inverter, I'm getting 1 in here. And when R equal to 1 is taken and when it is passed through the NAND inverter, I'm getting 0 here. Let us assume that my previous state is 0. Okay, previous state is 0. That 0 is passed through this one and I'm reaching in here. Tell me, guys, if I have 0, 0 in here, what will be your NAND output, guys? What will be your NAND output?
1 sir.
1.
1,
And-
sir.
And that 1 will be passing through this path and will be reaching in here. Guys, tell me if 1, 1 are your inputs of a NAND gate, what you will get as your next state output?
0
0.
Guys, that is what is very important here. When S is equal to 0 and R equal to 1 is taken, always your output will be 0. Always your output will be 0. And that state is called as reset state. That state is called reset state, guys. Okay. So the third condition also over, guys. First of all, I have taken S is equal to 0, R equal to 0, and I call it as no change state. Okay. In the second state, I have given S is equal to 1 and R equal to 0, and I call it as a set state. In third condition, we have seen I have taken S is equal to 1, S is equal to 0, and R equal to 1, and I call it as a reset state now because I got your output as 0 in here. Guys, let me go for the next condition. Let me go for the last condition, guys. That I will take S is equal to 1 and R equal to 1 now, guys. Okay, I will take S is equal to 1 and R equal to 1 now. Let us see how the operation can be carried out in here. Okay, let me see how we can carry this operation. Guys, now I am taking S is equal to 1 and R equal to 1. If 1 is passing through the NAND inverter, I am getting 0. And if this one is passing through this NAND inverter, I'm getting 0 again. Let us assume that I'm having 1 in here. Let us assume that 1 is available in here, guys. That one will be reaching in this place. Okay, that one will be passing through here. Guys, tell me if 1 and 0 are your inputs, what will be your output, guys? If 1 and 0 is your input,
1,
what will be your output, guys? 1 here. That one will be reaching here now. That one will be reaching here. Guys, again tell me if 0 and 1 are passing through the NAND inverter, what you'll get?
1,
One here. So, guys, you observe one thing. What is happening in here? What is the value of Q you got? What is the value of Q you got now?
1, sir.
1. What is the value of Q bar you got now?
1,
1. Guys, is it possible to get same value for Q and Q bar? Is it possible to get same value for Q and Q bar?
No,
If Q
sir.
is 1, the Q bar must be 0. If Q bar is
0.
1 and Q must be 0. These two things be complement to each other or inversion to each other. But in this case, I'm getting Q equal to 1 and Q bar equal to 1. Okay, so let us assume that ఒకవేళ మనం Q equal to 1 assume చేసుకోవడం వల్ల ఈ కండిషన్ లో మిస్టేక్ వచ్చిందని అనుకుందాం. Let us go for the different condition. We'll take Q equal to 0 now. ఒకవేళ Q equal to 0 తీసుకుంటే కరెక్ట్ కండిషన్ వస్తుందేమో చెక్ చేద్దాం మనం. Okay, again this one is passing through the inverter and getting 0, and again this R equal to 1 is passing through the inverter and I'm getting 0, and we are assuming that Q equal to 0 in here. That 0 will be passing and reaching here. Guys, tell me if 0 0 is the input of a NAND inverter, what NAND gate, what will be the output you will get here?
1,
1
sir.
here. Okay, let us move this one to this place and tell me what you will get as a next state now. 0 1 through the NAND gate. What you will get? 1 here. 1 again. So again in this condition also, you are getting Q and Q bar both as same values. Is it possible, guys, to have Q and Q bar same value? Is it possible, guys, to have a Q and Q bar same values?
No, sir.
Not at all possible, guys. Not at all possible. So when you are giving S is equal to 1 and R equal to 1, okay, you are getting both Q and Q bar as same values, which is highly impossible. Which is highly impossible. So we cannot determine whether the given latch, SR-Latch, is under no change condition, or else it is under set state, or else it is under reset state. So we cannot determine in which state that latch is available. So we call this state as indeterminate state. Indeterminate state. We cannot determine in which state that latch is available or it is stored. So we call it as a indeterminate state. Indeterminate state we call it as, guys. Okay, guys, I have clearly explained you what are the states that are available for a SR-Latch. Okay, what are the different conditions we can have for SR-Latch. Guys, using these conditions or operation conditions, let me derive a truth table here, guys. So let me derive, guys. I am taking my first input S and R. Okay, along with that I am taking my present state value Qn. Guys, let me take Qn as my present state value. That is what we have assumed, guys. Okay, and let us assume that my Qn plus 1 is the next state what we have got, and we'll write what is the name of the state. Okay, name of the state we'll try to write in here, guys. Okay, guys, now you tell me what are the conditions I can take, input conditions I can take for the table. This is the truth table we are drawing from the observations what we have seen from the circuit operation. So what are the inputs I have taken, guys?
Equal to 0 or equal to
Yeah,
0.
S is equal to 0 or equal to 0. And what is the previous state I have assumed or present state I have assumed? 0 initially. Guys, you understand, and ఏదో blind గా చెప్పదండి, అర్థమైన విషయం చెప్పండి. When I have taken S is equal to 0 and R equal to 0, and when I have taken my present state is at 0, what you got as a next state? 0, guys. Okay, 0. And next condition, when I have taken S is equal to 0 and R equal to 0, and when I have taken present state as 1, what is your next state you got, guys?
1, sir.
1. So this is my first condition, guys. When S is equal to 0 or equal to 0 is taken, when present state is 0, you got next state as 0. When present state is 1, you got next state is 1. So present state ఏదైతే ఉందో అదే next state గా వస్తుంది కాబట్టి what we call this as, guys? What state we call it as?
No change state.
Yeah, we call it as, okay, we call it as no change. Okay, no change state. Okay, we call it as no change state, guys. Now let me go for the next one, guys. I have taken the next input as S is equal to 1 and R equal to 0 when present state is 0. S is equal to 0 and R equal to 1 when present state is 1. Guys, tell me what you have observed from S is equal to 1, R equal to 0 condition. When it is 0, what you have observed? You can see here, guys, set is high. Set is high. Okay. When S is equal to 1 and R equal to 0, when present state is 0, what you have observed, guys?
1, sir.
And when I have taken 1 equal to 0 and S is equal to 1, R equal to 0, present state is 1, what you have observed?
1, sir.
1 always. Guys, this is exactly right. When S is equal to 1 and R equal to 0 is taken, always your output must be 1. ఎప్పుడు 1 గానే ఉండాలి. That is mandatory case. Okay, and we call this state as set state. ఎప్పుడైతే సెట్ హైగా ఉందో అవుట్పుట్ 1 గానే రావాలి, ఆ స్టేట్ మనం సెట్ స్టేట్ అని పిలుస్తామండి. Now let me go for the next condition, guys. When S is equal to 0, R equal to 1 with present state 0, when set is equal to 0 and reset is 1, and when my present state is 1. Okay, guys, tell me what are the outputs you have observed in this condition? What are the outputs you have observed in this condition?
Sir.
0. And for this condition?
0, sir.
0.
0.
And what state I can call this as, guys?
Reset.
Reset state. Okay, reset state. Exactly correct. And now let us go for the last condition, guys. That is what is left alone. When S is equal to 1, R equal to 1, with present states as 0 and 1. With present states 0 and 1. Okay, guys, tell me what are the outputs that you have observed? What are the outputs you have observed, guys? Guys, let me go fast. You can't find what is your output. It is indeterminate state. Okay, both Q and Q bar you are getting as 1, so which is wrong state or indeterminate state. So we will place don't care in here. Don't care. Since we don't know what is your output. Output ento manaku teliyadu kabatti proper ga, and we are calling it as indeterminate state. Okay, indeterminate state this is actually. Okay, guys, do you understand the truth table of SR-Latch here? And you got the point? Yes. Guys, understand one thing? I think you are okay with these 3 states. In the last state, when I'm taking S is equal to 1 and R equal to 1, irrespective of your present state ఏమైనా కూడా అవుట్పుట్ మనకు తెలియదండి. Since you are getting Q and Q bar as same values, అలా జరగకూడదు కాబట్టి we cannot determine what is its output. So we call that as indeterminate